How are you, my good people? How are you? How is your morning? How is your afternoon? How is your evening? How is your night? Those who are watching me from Kenya, how is Kenya taking you? Those who are watching me from abroad, I notice you. How are you? I hope you're well too. I take this opportunity to thank you who has joined us just recently. You have just joined a big family. We are growing very fast. Thank you for being part of this family. May God bless you. The returning subscribers, you are very much welcome also. Thank you for keeping in here, supporting me now and then. God bless you. There are those who have been watching me and they have not subscribed yet. Please find it in your heart to support me by just clicking the subscription button. It's very free. That will make me be in a position to reach so many people outside there as we reach out to so many students. Today I want us to tackle this most feared part of the syllabus about titration and its calculations. And the funniest thing is, students fear it, not knowing that it is actually the most simple part of the chemistry syllabus. Why do I say that it is simple? It's because it's all about calculations, and calculations has one secret that if you are able to know the concept, if you are able to know which formula to apply where, how to write equations and balance them, then you are good to go. So stop fearing titration and its calculations. It's one part of the practicals that can boost your grade. So as we begin, please check on your attitude about these calculations, as when you have a negative attitude, you will always fear it, you'll always fail. But when you have a change of attitude, you have a positive attitude, you believe in yourself, then you will get it all right. And know that God blessed you with good mind, good brain, then why not pass even in this one? You are able. Please, just have a try. Let us take a risk and try your mind. And you'll see, by the end of it all, you'll have grasped even though 1%. Then if you continue practicing, you'll continue to add into the 1%, and before you know it, the 1% will add 2 zeros, and you know what? That will be 100% success. So may God bless your mind and your brain too as we begin. So today I just want us to have the question, you copy it, you think about it, then in my next episode, in my next lesson, I will take you step by step. So the headline that I have given it is that this is a question on volumetric analysis, and basically I want us to have the calculation on R.F.M, that is relative formula mass, and R.A.M, relative atomic mass using titration results. So about titration, for you to be in a position to do the calculations, you must have done the practical in the lab and filled the table. But for this one, to make it easier for you, because we may not meet in the lab, actually I will have given you the results. So it's just for you to write the question, try it before we meet and tackle it. So let me read it as you write. A solution A was made up by dissolving 2.65 grams of a metal carbonate, and that is the formula there. The metal carbonate is X2CO3. X is just a letter representing a certain element that by the end of the question you'll be required to get the R.A.M of it. So made up by dissolving 2.65 grams of a metal carbonate, X2CO3 in water, and diluting the solution to 250 centimeters cubed. B is a 0.25 molarity, that is capital M for molarity, solution of dilute hydrochloric acid. 20.0 centimeters cubed portions of A were titrated with solution B using methyl orange indicator. These are the burette readings. We have the final readings. We have the initial readings. And then we have the volume of solution B used. So I hope you can see the table. We have the trial. We have the first titer, the second, and the third. So that is the table. I hope you can see it well. We have the burette readings. There we have the trial, the first, the second, and the third. Then we have the final readings in centimeters cubed. In the trial we have 16.6. The first one we have 32.6. The second we have 48.6. And the third we have 16.0. Initial readings again in centimeters cubed. In the trial we have 0.0. In the first we have 16.6. In the second we have 32.6. And in the third we have 0.0. Finally, we have the volume of solution B used in centimeters cubed. We have in the trial 16.6. In the first we have 16.0. In the second we have 16.0. And in the third we also have 16.0. So those are the titration results. I've given them to you. As I have just said, it's for the reason that we are not able to meet and do the practical one-on-one. Then we go to the questions. The first question, calculate A, average volume of solution B used. The first question, calculate A, average volume of solution B used. B, write the equation of the reaction. C, calculate the concentration of the solution A. Calculate the concentration of the solution A, Roman 1, in moles per liter, that is the molarity. Roman 2 in grams per liter, remember grams per liter. In the previous lesson we said it is also gram per dm cubed. Now that 1 dm cubed is the same as 1 liter. D, calculate the relative formula mass, into bracket R.F.M of X2CO3, the X carbonate. E, calculate the relative atomic mass, that is the R.A.M of X. By the time we are getting to question E, where we will be getting the relative atomic mass, in some type of way, we will be in a position to even identify what X is, which metal is X. So write the question, write the questions. That is those are the questions. We are getting the average. Try and get the average. B, you write the equation when you hear that you are writing the equation. When you hear that you are writing the equation, remember this is the equation where we use chemical symbols. Actually, this is a chemical equation. Even though it has not been indicated there, the type of equation that you are needed to write is a chemical equation. A chemical equation is where you use the chemical symbols, and again it must be balanced. Let me remind you a bit of what is needed when you are writing an equation. You must first of all use the correct chemical symbols. You use the correct chemical symbols to write the formulas of each and every compound, each and every gas, if a gas is needed. For each one of them, write the correct formula. And writing the correct formula means you have used the correct chemical symbols. Number 2, for you to write a correct chemical equation, you need to indicate the correct chemical, you need to indicate the correct state symbols. About the state symbols, some of the students are not able to know which ones they are. You just need to remember the 3 states of matter. Once you remember the 3 states of matter, then you already have 3 state symbols. So because they have 3 states of matter, one is solid, so if anything in the equation is in the solid state, you write a small s into bracket. If anything is liquid, you indicate a small l into bracket. If anything is a gas in the equation, you indicate a small g into bracket. Then, apart from the 3 states of matter that you all know, we all also add another 4th state symbol, and this is when you mix a liquid and a solid. When you mix a solid and a liquid and they dissolve completely, then you end up with a solution. And when we are indicating the state symbol for anything that has dissolved, you say it is in the aqueous state. The aqueous state has some knowledge of the aquatic animals. That is how I assist the students to remember. Aquatic animals, they live in the water. So aqueous, aqua has something to do with the water. So aqueous, those which has dissolved in the water. So you again, those that has dissolved in the water, you put an AQ, small a, small q into bracket. And when you're indicating them, the state symbols, then you make sure that haujaziandika hapo chini ya kila compound ama kila part of the equation. You write them after you write, for example, for oxygen, you write O2 hapo mbele ya tu, mahali umeandikia tu, sio hapo chini ya o ama chini ya tu, in a way that ukiweka a straight line hakuna kitu kitaachwa chini. So I will show you practically what I mean as we do the question in the next lesson. Then finally, if you need to write a correct chemical equation, the equation must be well balanced. So a correct chemical equation should, one, be written using the correct chemical symbols. You use the correct symbols. Number two, you indicate the correct state symbols. Then you also balance it, and by that everything will be very correct. Then you also needed to calculate the concentration of the solution A in moles per liter or moles per dm, that is the molarity, in grams per liter, calculating the R.A.F.M and also the R.A.M. So let me also put the question in a way that you'll be able to write it. I hope that you can see it. A solution A was made up by dissolving 2.65 grams of a metal carbonate X2CO3 in water and diluting the solution to 250 centimeters cubed. B is a 0.25 molarity solution of dilute hydrochloric acid. 20.0 centimeters cubed portions of A were titrated with solution B using methyl orange indicator. And those are the results. I hope they are legible enough. So remember, the question is on volumetric analysis. I want to show you how we can calculate R.F.M, relative formula mass, and R.A.M, relative atomic mass, using titration results. So that is all. So before we meet in the next lesson, make sure that you try. Just do a try. Try doing the question, and let us mark together. And where need be, ask any question that you'll be having in the comment section. If you are a student and you're watching me, please tell a friend that there is this channel that is willing to assist you in your revision towards your final exam. It's only that I cannot come to your home to take you through the revision, and I have just thought about you, that inside this channel, at least we can have a meeting point. So may God bless you. Please do not leave before you subscribe. Please also like, please also share with your friends, and may God bless your memory. I love you. May God bless you. Thank you.